Hello, everybody. Welcome to today's session on low latency data serving in Snowflake with hybrid tables. Today, we'll walk through a demo to see how hybrid tables helps with high concurrency, low latency workloads. My name is Nagesh Cherukuri, and I am a field CTO, the principal data architect at Snowflake. First, as we go through the agenda, we'll explore what specific problems hybrid tables solve and where they fit in your technology stack. Then we'll dive into the architecture. I'll break down the key components and show how they work together to deliver high performance. We'll also go through the data model and we'll examine how hybrid tables are structured differently from traditional approaches and why this matters for your applications. Then we'll go through a load test using JMeter. I'll walk you through the criteria and the results. I'll conclude with showing you a microservice API, which we build on top of hybrid tables, how you can access from your embedded analytics applications. By the end of this presentation, you'll have a clear understanding of not just what hybrid tables are, but how they can be practically implemented in your environment. Let's go through what hybrid tables are and what capabilities they provide. Hybrid tables provide several new capabilities that help you, the customers, build data-intensive applications on Snowflake. They enable fast point operations by a new row storage engine, which serves as the primary data store for hybrid tables. And we do deep optimizations for these transactional workloads in the cloud services and virtual warehouse layers in Snowflake architecture. We provide support for primary key, foreign key, and unique constraints, which enforce data integrity within your application. In hybrid tables, we provide row locking instead of table locking, which facilitates high concurrency random writes. Indexes provide fast lookups for common access paths. The best part is that they are seamlessly integrated within your existing Snowflake databases, so you don't need to move data out in order to leverage them. They sit alongside your standard tables. So we go through an imaginary use case. Let's imagine we are a SaaS provider for a company called Marketing Metrics Pro, which is an imaginary company, which provides market campaign metrics to their customers. As a SaaS provider, we are responsible for providing metrics to customers for different channels and within specific dates via dashboards and API as access patterns. Let's walk through, what are the things we are going to provide in this particular example. Since we are a market campaign metrics provider, we consume metrics from different channels. Like I've taken an example of Google Analytics, Instagram, so on and so forth. Those data gets ingested into Snowflake. And once they get ingested into Snowflake, we do some data transformation, data aggregation, pre-compute the data, and push the data into hybrid tables, which in turn acts as the backend for your front-end dashboards or embedded analytics applications. Your embedded analytics applications can use an API to connect to the hybrid tables, and your dashboards can use JDBC to connect to the hybrid table to power those dashboards. And hybrid tables basically provides you with that fast point lookups. That's what we are going to demonstrate today to power those dashboards or analytics applications. The advantages, the benefits of hybrid tables are, as I said, it provides fast point lookups because we provide indexes. We support simplified architecture. The reason you're not moving the data out, the data is being served from one Snowflake platform. Both analytical as well as operational data is sitting in one place. You have a row store serving your operational queries via hybrid tables, and you have columnar store serving your analytical queries. And the other benefit is unified data governance, where we govern all of your transactional and analytical data with one central set of policies. Your security and access policies including column masking, row level security, work seamlessly with hybrid tables out of the box. So those are the benefits you get with hybrid tables. And let's dive deep into the architecture of this particular use case on what we're going to build and do a load test to see how hybrid tables perform. So as you look at the architecture, which I just put it here to illustrate the use case which we are talking about, we have different marketing channels who are pumping the data or ingesting the data into Snowflake platform via Snowpipe streaming, Snowpipe. And once the data lands in Snowflake, the data lands in standard tables. Once the data lands in standard tables, you can do data transformation using your different features in Snowflake like streams and tasks, dynamic tables, Snowpark. Once you transform the data, pre-compute the data, you can pump the data into hybrid table called, in this case, pre-aggregated campaign, which is a row store underneath the covers, which is going to be acting as the backend for our dashboard applications and any analytical applications which are accessing that data through an API. In this example, I used a API framework called Fast API, which can be used to power the API so that the embedded analytics applications can use that to access the data from hybrid tables. Your traditional dashboards like Tableau can connect to the hybrid tables using traditional JDBC driver. That's what we are going to show, both those access patterns in this demo. Before we jump into demo, I also want to cover the data model. As you can see, the top 4 tables are standard tables, Snowflake standard tables, where the data get ingested from all these channels, all these marketing channels like Google Analytics, Instagram, so on and so forth. Once the data gets into standard tables, we use traditional features like dynamic tables, streams and tasks, Snowpark to pre-compute, to aggregate all the data, and on a schedule, ingest that into a pre-aggregated campaign table, which is a hybrid table. And that table has a composite primary key of customer ID, channel ID, and date, which helps us to do the fast point lookup for a particular customer on a particular channel on a specific date. And I illustrated with a dashboard which can be built on top of that hybrid table, which will basically power your analytics or your dashboards. Because the data is pre-computed and in a row store, you will get that fast point lookups because we indexed that on the primary key. With that, I would like to talk about the demo, how we are going to set up this demo. If you have a requirement of 200 queries per second throughput, and that's, let's say, a peak where your customers are coming in and they're requesting 200 queries per second from the system because on a particular day, at a particular time, you might have a load requirements. And I wanted to simulate that here with a JMeter client, which is running on an EC2 instance, connecting to Snowflake in the same region, and simulate the same workload as the customer. There are peak customers of which are generating 200 queries per second as a throughput requirement. And once we are done with the demo, let's also analyze the query performance in Snowflake with a system aggregate query history view, which will provide you latency metrics on the server side. With that, let's go to the demo. So now we are in the Snowflake Snowsite worksheet. This is a SQL worksheet. And here I'm going to stage the data which is going to be coming from different marketing channels. Since this demo is focused on hybrid tables, I will pretend, or I'll simulate the data into a hybrid table called pre-market campaign. And I'm going to seed the data with 1.6 million rows. So instead of standard tables ingesting that data into hybrid table, I am creating a stored procedure to really simulate the data for 1,000 customers across 6 channels from January 1st of 2024 to end of September of 2024. So that basically gives us a combination of 1.6 million rows. And what I'm going to do here is I am going to create that synthetic data using a stored procedure. As you can see, I'm going to do a bulk load and create a hybrid table called pre-aggregated campaign. Okay. So I'm going to create that stored procedure. As you can see, that stored procedure is created. Now I am going to call that stored procedure, which is going to generate that 1.6 million rows representing 1,000 customers um, across 6 channels. And as I said, from January to September of 2024, 273 days. So it'll be generating a combination for each customer, each channel, and every day in that time period. Bingo. We created approximately 1.63 million rows, and we seeded the hybrid table. Let's verify the count. As you can see, we have 1.63 million rows in the hybrid table. Let's eyeball the data to see for each customer, each channel, there's 273 days, so 273 records. So we have properly seeded the data in hybrid table. And as you can see, it's properly populated for every column. This is good. So now we have preset the data in hybrid table so that we can perform that load test to see how the performance is going to look like when an API or a JDBC call is made from the applications. So this is the query, a select query, which I'm going to use to power the dashboard for our fast point lookups. As you can see, I am basically giving a customer ID and a date and a channel. The combination of this, you'll get a fast point lookup for getting this data to power the dashboard. So let's eyeball that data. So for a particular customer, I can see that all the data is pre-populated. I am going to use the same exact query in JMeter and execute it from JMeter running on an EC2 instance in AWS to simulate that load. So I'm now showing my JMeter where I'm going to set up a test to basically simulate a load of 200 queries per second. Assume that we have customers every Monday morning and there's a peak load of 200 queries per second for a sustained period of 15 minutes. And probably there might be a ramp up for first 5 minutes where customers are coming in and looking for their particular customer for that channel for a specific day or a period of days. That's exactly the test I simulated here, where first 5 minutes, the threads are going to ramp up to 10. And from there, for the next 10 minutes, it's going to be stable state. As you can see here, the ramp up time is first 5 minutes is 300 seconds. 10 threads are going to ramp up. And after that, it's going to hold steady with that 10 threads for the next 10 minutes, which is 600 seconds. And we want to limit the throughput at 200 queries per second, just to simulate the load like what we see in the real world. That's why I put 12,000 here, 12,000 samples per minute, which represents 200 queries per second. And the JDBC request, which I have shown you in the Snowsite worksheet, is a fast point lookup, but I randomize the query inputs to different customers from 1 to 1,000, channels between 1 to 6, and any date between January 1st and end of September. So that's the query. I'm going to fire it, as I said, from an EC2 instance running in AWS. I'm going to log into that instance. And I'm going to go to my JMeter. And I'm going to basically show you my script. And this is a script which you just saw. I just brought it on to AWS, an EC2 instance. As I said, the throughput is going to be 200 queries per second. I'm going to limit it at that. And this is my select query, which I'm going to be executing via JMeter to create the load, to simulate the load on the hybrid table, which we just created and seeded. I'm going to execute that test with some heap, some storage, and I am going to change the output where it needs to go. I've executed this test many times, so I'm going to execute it here. Now, what it's doing is it's opening a JDBC connection from EC2 instance on AWS to connect to Snowflake instance in the same region. And that Snowflake instance we seeded with all the data, as you saw, 1.6 million records. That's what this is hitting. And it's going to ramp up, as you can see now. We have one thread here, but as the test goes over time, it's going to ramp up to 10 threads. And as you can see, the queries per second is the throughput. Currently, it started at 6.8 queries per second, but as the threads increase, your throughput increases, as you can see here. Now, while this test is executing, I want to switch back and show you, how it's going to look like from the server side, in terms of load. If you go here, again, back to Snowflake Snow site, you have the ability to look at query history. You also have the ability to look at the warehouses. So I am using my HT XS small warehouse. As you can see, it's one cluster. And right now we are executing the test. So you can see that it's running and the queries which are being executed here are shown here. Okay. And you also have the ability to see the grouped queries because you're hitting that with a load. Most of the hybrid table queries will be shown here because each of those queries have a parameterized query hash, which I'm going to walk you through what that is, and those will show up here. This is currently in preview, so the grouped queries will be available to you soon once this is once this feature goes live. But meanwhile, you also have the ability to go and look for aggregate query history, because all the hybrid table queries will not be appearing in query history. Instead, they will be appearing in aggregate query history, a system thing called aggregate query history view that will basically provide you with metrics on how this is being executed. Okay. So I am going to show you how to look for those queries, how to look for that server-side metrics on how this test is being executed. Since I executed this test a while ago, I wanted to, instead of waiting for the test to complete, let me execute a query to find the query parameterized hash in the aggregate query history view, which will give you this query parameterized hash that using that you can find the metrics of that. So I'm going to execute this query parameterized hash view on the aggregate query history view, which basically gives you a query parameterized hash, which you see down below, that tells you how many calls were made, right? We are making continuously that select query, a fast point lookup with with wide variety of input, and we want to see the latency of that. That's what we're trying to do here, right? Once you find the query parameterized hash and the number of calls, you execute this query again on aggregate query history view using that query parameterized hash which we captured. This basically provides you with the P50, P90, P99 view of the calls. You can also eyeball them using a chart which shows you, the P50, P90, P99 over time to really see how this is performing. So as you can see, most of the time P99 is 22, 23 milliseconds. And let's also observe this from the the JMeter perspective. Once the JMeter is done running the test, it will show you the results. I'm going to walk you through the captured results while this test is running. So let's observe the test. As you can see, the test is running still. It is in the minute 5. We have 200 queries per second, and all 10 threads have started and are active. Now this test is going to continue, as we talked about, for the next 10 minutes with stable state, and it keeps on sending 200 queries per second, and we are getting the throughput from the server side. Okay, I'll leave the test running, but I will show you the results which are already captured from the previous test to see how it looks like. So here we show you the test results, which captured this before. Instead of running for 15 minutes, we ran this test and we sent a sample size of 165,000 over 15 minutes. As you can see, your P99 is 39 milliseconds and your median and average are at 26 milliseconds. Okay, and the throughput is at like 184 just because we ramped up for the first 5 minutes. Once we ramped up, we stayed consistent at 200 queries per second. On the response time, as you can see, we are 30 milliseconds all the way through. That's why we get a P99 of 39 milliseconds, and P90 and P95 are 29 and 31 milliseconds. So it's giving those fast point lookups, the low double digit milliseconds. That's the power of hybrid tables, which is powered via row store. Let me switch to the next step, where we talked about how do we build an API on hybrid tables. Like we build an API on any standard tables. It's no different. In this example, I used Fast API framework to build an API which connects to the backend hybrid tables using JDBC. As you can see, I built one API called get campaign metrics, and the query parameters is the customer ID, date, and channel ID. But I also expanded it so that you can search for a specific date range. All are optional. In this case, I provided an example where I provide customer ID, channel ID, and date, and which gives you a fast response so that you can use it in any analytical dashboards. Let me demonstrate how I did that. I'm going to stop this test, which we started earlier, because I captured the results and I showed you, I presented you. From this AWS instance, I am going to demonstrate what I did to install this Fast API application. I have a Fast API app installed here, and I just wrote an Python-based file to connect to Snowflake using my parameters, my account, my user, my warehouse. And I'm executing the same query which I showed you in Snowsight dashboard by passing in the parameters coming in from the user request. So I'm going to call this using curl. Just to make it dynamic, I'm going to change the customer ID to some 1, 2, 3, any number between 1 to 1,000, as we have 1,000 customers, any channel between 1 to 6, and any date in 2024, I'm going to change it to 519. As you can see, the response is quick because we're going to the hybrid tables and we're getting the response in a low latency fashion. With that, I conclude my presentation, and let's see what are the few key takeaways from this presentation. Hybrid tables are here to empower the next generation of data applications. I have demonstrated here today how we can do low latency data serving at high concurrency. We capped the limit at 200 queries per second to illustrate with an example of a peak load, how it's going to look like. We simplified the process for building data-driven apps by having all the data in one place. We don't have to have a OLTP engine alongside to serve this low latency use case. We streamlined the development process. We have built all of it on Snowflake, both analytical queries and the transactional queries are sitting side by side in the same platform. The scalability, I demonstrated 200 queries per second today, but you can linearly scale out by having multi-cluster warehouse um, to address these scalability requirements. And I have demonstrated performance P99 around 39 milliseconds. So low double digits, we can serve low latency, high concurrency use cases with low double digit milliseconds. And I also showcase that we have unified data management, both analytical and transactional data workloads can be served from same platform. With that, I conclude my presentation and thank you all. Thank you all for attending the session. We are excited to see what you're going to build on hybrid tables. Hybrid tables power next generation data applications along with all the analytical use cases we powered so far. Thank you. Thank you, one and all.